My name is Kenny Keith. I'm a machinist here at the Eastern Kentucky Advanced Manufacturing Institute, and I started machining in May of 2019. Star Wars has meant a lot to me. I grew up with the original trilogy and then later the prequels, and now I'm able to enjoy the latest trilogy with my kids and see them experience it for the first time. For this project, I was using 6061 aluminum for the wings. They're 3 inches by 3 inches stock, and the body was 1.5 inches round stock. I really wanted to push myself going into it. I hadn't done any 4 or 5 axis work to this point, so I knew going into it that I wanted to try that and learn that. So with the design, I set out to do a 2D design for the wings. I did a basic line drawing with the 2D toolpath. But on the body, I knew I wanted to rotate that in the 4th axis and machine it that way. So I set out to learn how to do that and to program that and toolpath that using Mastercam. Once I had started the wings, I realized that I had a lot of chatter doing the backside, so I machined a set of soft jaws to hold that and reduce that chatter down and to give me a better surface finish on there. I'm very thankful for this opportunity to continue to grow and learn as a machinist. It's a joyful process. I love creating things and seeing things designed with the CAD CAM from Fusion or Mastercam. And not just seeing it on the screen, but actually making the part in the machine, seeing the chips fly, cutting the metal down, all the aspects of it. I love getting in there and making something with my hands. It's just something I really enjoy doing. So I was really pleased with the final product. I did have some chatter issues, but I sanded those down. You can still see some surface finish issues on the back and the top of the part, but they don't really stand out too bad. I added the antenna to the side, as well as the 2 guns under the undercarriage of the cockpit of the body. I did that. I took it over to the drill press and pre-drilled those holes for the body, and then I machined the antenna as well as the laser cannons to be inserted in there. I did a CNC program through Mastercam to mill those out of a scrap piece of aluminum, and then just filed them down and inserted them right in. I really enjoyed this project. I learned a lot about 4-axis machining and planes and keeping my orientations right, keeping my axes right. I learned a lot about 3D toolpath and multi-axis toolpath. I hope to continue to learn as a machinist. I really have grown to love this profession and enjoy what I get to do every day, and I'm thankful for this opportunity.
This is Matt with Specter ETM. Hey, I'm going to take on the tie challenge. Is that Harry Potter or Star Trek? Just want to show you the model that I came up with. Took an image off of Google Images and kind of modeled it up from there. I did this in 2 setups. I did an area, 3-axis area clearance, where it basically clears all the stock material. Then here's a Z level where it slices everything in your XY plane at a specific distance. This was with a 1/4 inch 20 thousandths hog nose. And then I do a Z level with a 3/32 ball mill. Then I do a pattern project, which slices it perpendicular to what your Z level would be, and then you give it some cut angle. Like you could do like 45 degrees. I did 90, so it was going to run back and forth this way instead of back and forth this way. I go through, do exactly the same thing. Only thing different this time is that I drill the holes.
Alright, so I'm going to take this piece of 303 stainless steel. It's about 1 inch in diameter. It's already been ground stock, and I'm going to go ahead and put it in 2 5C collets at both ends. And there's the setup. Just pretty simple. I'm going to hold them on both ends, clamp them down on each end, and that'll help with vibrations. So I went ahead, went across that, and got about 2/10 over that distance.
We are opening a package from Matt at Specter ETM. Not every day you get to open a TIE Fighter. Or I'm assuming it's a TIE Fighter, who knows? Someone has already trolled me by sending me a TIE Fighter, which was a picture of a person from the country near Vietnam doing a kickboxing routine. See some ion engines here. Oh, this is gonna be cool. This is awesome. Card here to the tour we did at Specter ETM down in Cincinnati area. Really cool. Dude, this is beautiful. Julie, look at the detail on this.
My name is Karl. I live out in Bremerton, Washington, and I am going to be machining a TIE Fighter for the NYCNC project number 1.
I'm going to start off with a little time lapse here of the body. We start by machining with a multiple tool path here, and the initial tool worked out just fine, but we ran into some issues with the second tool. There were some tool offsets that were problematic, as seen right. Oof, that hurts. Thankfully, no tools were broken, just had to reseat it. So I decided to turn a high-speed steel piece of tooling and then do the entire operation with a single tool. Here's the overall time lapse for that. It ended up working pretty well. There are a couple things that I would change if I was making more than a one-off, where the ends were not quite done as well as I'd like, and some finishing operations could have been optimized. But overall, the surface finish worked out pretty well, and the cycle time for this was about 45 minutes, I think, when it was all said and done. So for the entire operation, I've been using Linux CNC for the lathe here, and it has been treating me very well. The Tag Turn Series lathe is really good working in aluminum. Once the bulk of it was done, a little bit of polishing with some abrasive, and here's a beauty shot. Moving on to the radiator fins, this was done on a Shapeoko 3, and the cam basically is a big adaptive profiling and then some cleanup passes. I initially had some issues with some work holding as seen there, but it was quickly sorted out and we got some good pieces. Here's the complete time lapse. 4 of these were made. They all turned out pretty well. One side has a hole in the middle and the inside does not. And this is what it turned out with. Overall, I'm pretty happy with the final outcome. There is a seam on the middle part of the radiators due to the epoxy filling in between the two. This could be removed if the machining was done by flipping the part over. I did attempt to do that once. It did not turn out well. And I also did not have a thick enough piece of material locally available, so I had to basically make 4 pieces, and then all of the parts were epoxy glued together and let sit. This also allowed me to get away with some not so great tolerances on the bore, but it seemed to work out pretty well. I want to say a big thanks to NYCNC for pushing creators like myself to create things a little outside of our comfort zone. It's the first time I've actually made anything in aluminum on the CNC router, and it has been quite an adventure. Thank you guys. Keep up the good work.
Apparently he's on a boat somewhere in the west coast or the Pacific Northwest. It looks also really early in the morning, so maybe a commute. I'm expecting to get pranked by one of these, like Adam Booth, Tom Lipton, like something just flies up in your face. Concentric machining, Bremerton, Washington, turning, welding, milling, repair. Cool. Oh, look at that. Sweet. Looks like he did a nice blast on it. A bead blast. I like it.
Hey, this is Justin with NERO Industrial out of Little Rock, Arkansas, and this is our entry in the NYC CNC TIE Fighter Challenge. I think I may have misread the contest title a little bit. Ended up with a intermodal TIE Fighter, shipping container, 3D printed. Snaps out with some spring detents. Everything else is 6061 aluminum. It's about 2 feet long, a foot high. All the lathe work was done on a 90s government auction Akuma. All the mill work was done on an import router. And that's how Fab Shop, which is what we are, tries to get in the machining game on a budget. All the CAD and CAM was done in Fusion 360, and I'll go over some of that now. This is the final design I ended up with. It's made of 25 individual components, including the fasteners, and the most complicated part of the machine ended up being the cockpit area. It's made of several different pieces machined separately and then pressed and screwed together.
Hey everybody, Mike Baryla here from Walmart Supply. I was really excited to actually try to tackle this TIE Fighter. I've actually only been machining for about 1.5 years now. We've been fabricating, sheet metal, have robot welders, lasers, all kinds of stuff like that. So as far as fabrication goes, I'm really comfortable in that realm, but machining is pretty new to me. So everything was done on Haas on this one. So we have an SL20 with live tooling, a UMC 750, and a VF3 SS. So I tried really hard on this one, but some compromised setups. It was definitely interesting. To work holding was kind of fun. This was a fun shape. My buddy Richie Cart here, never mind, I don't know how to do that. He helped me out designing it, and he's going to be finishing it up, making it all pretty. It's over at his place now. So I put together this video with some clips of the process, how it went, what didn't go well, what went well, and I hope you guys enjoy it. Alright, let's take a look at these wings. Now admittedly there's a little chatter and everything. This was an actual job. I sit there and try to find a better way to hold these. I'm just holding them in basically two DB510s from 5th Axis. So there's a bit of flexing and a bit of chatter going on. We'll polish these out. It's really not a big deal, especially for something that's just kind of a novelty thing. So these are kind of big. Should look great. The inside hex, perfect dimension, so it bolts nicely up to the body, nice and tight, no wobble there. Making a few of these, so it's coming out really good. Hey everybody, so the TIE Fighter body, second op, is not working out too well for me. First off went great. Roughed it out fairly quickly, nice surface finish. Good to go. Richie and I decided to try to, he 3D printed these little end caps that go over really nicely to try to hold it in, but the 3D printed plastic just did not want to hold up to the jaws in the lathe, and I couldn't really get it to hold any kind of straightness or concentricity next to the chuck. So I'm gonna try something new here. Let's hope it works. Alright guys, this is gonna be either a really bad idea or it might just work. So I was able to find actually a 1 1/8 5C collet with a thread in the back, which I don't really know what you normally use this for because you can't pass anything through it. But anyway, I have this Edge Technologies little collet stop here that threaded nicely into the back of it. I'm going to try to get this as far on here as possible, chuck it up in the machine, and then put a bolt through the back of this into the actual threaded hole that's already there, which is nice, and pray to Baby Yoda that it doesn't fly out. Alright, so I can't say this is the most rigid setup I've ever done, but we got the TIE Fighter body in the UMC right now on some 1/4 inch brackets that we made. The legs have little hexes on them, which is nice because it was able to clock it basically onto these legs, and I needed to make them a little long for this operation right here actually to get those chamfers in. So it's going good, should be done here soon.
They may have banned toothpicks in California, but they sure as hell haven't banned TIE Fighters. This thing's got some weight to it, I'll tell you. I think it said 15 pounds on the box. Holy. Oh my God. Oh my God. Well done, internet. Oh my God. Take a look at his Instagram post. When he says compromised work holding, he's not kidding, but look at this. This is amazing. Props to anybody who's, again, doing lathe work on a mill. You know, near and dear to my heart. And I believe, we'll double check on the Instagram, but I believe this is actually a 3D printed insert of some kind. And look at these panels. Awesome, well done.
Hello, I'm Fedor from Ann Arbor, Michigan, attending Washtenaw Community College full-time. I got introduced to manual machining through the high school robotics team that I was on, Team 3322, and got introduced to CNC through NYC CNC. In high school, I was fortunate enough to live next to MakerWorks, an amazing makerspace in Ann Arbor, Michigan that has a Tormach 1100. So I just started trying to make parts on it, and then learned how to use Fusion 360 CAM through NYC CNC. And then just kept learning throughout the years, and I hope to eventually reach 5-axis machining and robotic machine tending, which is possible at the college. For the machining challenge, I decided to try to make a TIE Defender. I started off by learning how to use and program the small 4-axis mill at MakerWorks, which took a little over a week of modifying post-processors and machine parameters, but I finally got 4th axis indexing and simultaneous 4-axis to work properly. But then I tried to cut the Delrin material that I wanted to make the parts out of, and the machine just wasn't rigid enough. So then I decided to make the parts with the Tormach. I decided to make the tie in 4 parts using window machining for the wings and midsection, and for the cockpit do what the Tormach could reach, and then have the 4-axis mill do the ball and square. I first prototyped the way I wanted the wings to connect to the midsection, which turned out to be a snap fit, and then I decided to program a detailed STL from GrabCAD, converted in Fusion to BREP so I could interact with the file. Which was a mistake, because it took me way too long to program the wings and had to learn how to use patches to stop toolpaths going where I didn't want them to. By the time I finished New Year's present and the program for the wings, the next semester started, and time turned out to be my biggest challenge. I was unable to program and machine old parts in time, but quick tidbit that I haven't seen anywhere else from the present. If you ever have to deal with 2D geometry with tens of thousands of points, I would recommend extruding it and making it 3D, then moving and copying it around as you wish, and then either projecting it to get 2D geometry to drive a toolpath, or using the 3D to drive a toolpath. Back to the tie. Machining of the wings went quite well. I decided to machine the insides first so I could reach the angled tips of the wings on the second operation. When I was programming, I was afraid of pulling the Delrin out of the vise, so during roughing, I kept my step down low. First tool is a 3/8 end mill, 5,000 RPM, 60 inches per minute, 70% step over, 0.2 inch step down. Second tool was a 1/4 inch 3-flute ball, same parameters, and then finished at 60 inches per minute, 10,000 step over with the 1/4 inch ball. Next was a 16th inch flat, Same RPM, 10.2 inches per minute to the finishing, followed by a 1/16 inch ball, and then finally 1/32 inch ball at 5.1 inches per minute, 2,000 step over to do the small details. On the second side, the feed and speeds were the same, and one of the hardest things to program were the toolpaths that separated the part from most of the material. I ended up using a scaled toolpath to follow along the part, and then you used patches to stop it from going too deep, and then a 2D contour to leave tabs. For the midsection, I struggled to figure out how to program this inclined surface here, and I think a parallel toolpath driven by an offset body with a woodruff cutter would have worked in Delrin. Overall, I'm happy that I participated in this challenge and learned quite a bit more about programming in Fusion, and I plan to finish the tie. You can follow me on Instagram at Fedor Dolgachev.
Hey guys, you're in Germany right now. My name is Jan Roetz, and check out my TIE Fighter. I do have my own company. It's been up for the last 6 years since I finished my studies. And I mostly do work in prototyping industry. So I do basically whatever comes to my door in prototyping, designing and construction. Most of the stuff is basically for plastic extrusion industry. I got into machining during my apprenticeship as a mechatronic technician. I got used to working with CNC machines and stuff, and I was somewhat fascinated by the precision you could achieve with these machines and repeatability, and that you have to be somewhat innovative to be efficient with those machines, and that's what got me hooked in the long run. Most of the stuff I do is single part production, but you're also faced with work holding problems, etc. when you got very complicated parts. The biggest pain for me was to work with Fusion during that time, because all the highly detailed models and just the single core CPU usage didn't work that well for me. I had a lot of downtimes and crashes of the program, and during that time I wasn't really happy about it. If you have any further questions, please let me know. I'll try to answer them, and with that, we go to the final footage. Last but not least, I wanted to thank all of your team and all the other contestants. I really had a blast building this project, and since I can't send it to you, I will be having this as long as possible in my workshop. And yeah, I hope you continue doing such awesome projects, and I would love to be a part of it in the next time. So, may the force be with you.
Folks, that was absolutely amazing. Seeing folks' workflows, how they handled it in CAM, the machining, the fixturing, the work holding, 3D printing, putting it all together. Lights on these, absolutely amazing. And if you want to learn machining, you've got to pick a part and make it. Figure out how to model it, figure out how to fixture it, figure out those CAM workflows, find a machine and make it, whether it's a benchtop, hobby grade machine, or a full-blown VMC. If you want to be part of a future collaboration with us, we're going to announce them in our Chip Rag newsletter. Otherwise, folks, take care. See you soon.